Hello, everybody. So, we're really going to spend a bit of time in this discrete probability distribution idea, and we're going to talk about a specific one called the binomial probability distribution. It gets used a lot. The binomial probability distribution does, and because of it, we want to spend a little extra time discussing this. Now, for something to be a probability distribution, remember that the sum of any one of the events, the probability of any one of the events has to be between 0 and 1. It can be equal to 0, it can be equal to 1. And the sum of all the events, when you add them up, have to add to 1. Now, for it to be specifically a binomial probability distribution, you have to have some specific things met. So first of all, you have two outcomes. Now, this is weird verbiage. So they'll call the one you're focused on success, and they'll call the other stuff failure. So if you're sitting at an intersection and you're seeing the number of red cars that come through, red car would be success. If you see a red car, that's a success. If you see a blue car, that's a failure. So success is what you're looking for, failure is what you're not looking for, what you're not focused on. And in the world of creating two outcomes, we can kind of do the following. So whatever we're focused on is one of the outcomes, and then everything else gets lumped into the other category. So when we're talking about cars, if I'm focused on red cars, all the other colors fall in the failure category. Now, success gets often denoted as P, and failure often gets denoted as Q. And there's this relationship that they always talk about in that P plus Q is going to add up to 1. So the probability of the success plus the probability of the failure, they have to sum to 1. Okay, so P plus Q equals 1. A lot of times, at least currently, you're going to see authors will, instead of saying P and then Q, they'll say, and it's just auto-correcting and making it capitals, they'll say P is the probability of success, and 1 minus P is the probability of failure. But if you look at this formula here, 1 minus P just equals Q. So you'll see it denoted a couple of different ways depending on author and so forth. All right, so the first thing is you need two outcomes. The second thing is that the trials are independent. And what that really gives us is that the probability stays the same. So things that can be a binomial probability distribution experiment would be like rolling a die. And the reason is that every time for a roll, the probability of getting a 6 is always equal to 1/6. Probability of a 5 is always equal to 1/6, and so forth. Depending on wording, then you sometimes, like if I said the probability of a king, well, that's not going to work because the first time you draw a king, it's 4 out of 52. But once you've pulled that king out, that has changed the probability because there's less kings and there's less cards. Unless they throw in this statement with replacement. And once they say with replacement, then you pull out that king, you look at the card, and you put the king back in. So the probability of getting a king, and I'll write it a little differently, is 4 out of 52 every time if you have replacement. And that might be a better way to describe it. Now, you also have this thing called a fixed number of trials. So a fixed number of trials says, I am going to, well, let's go back to the car example, I'm going to look at the next 20 cars. It's a fixed number of cars. And I'm going to see how many of them are red. What isn't a fixed number of trials would be an example like this. I am going to sit at the intersection until I have 20 red cars drive by me. And so what that is that the number of trials changes, and it's not fixed. It's not a set number, and your number of trials could go off to 1,000. It could go off to 10,000 until that 20th red car travels through the intersection. So that is not fixed. All right. Now, those are the three conditions that are needed in order to be able to create a probability distribution. Now, I'm going to take, a binomial probability distribution. I'm going to take a very specific example, and we're going to say, we're going to roll a die 4 times. Okay. And what we're going to be looking for and what we're going to consider is a 1 or a 2 is a success. That means a 3, a 4, a 5, or a 6 is a failure, which is fine. I mean, this is just what we're going to be focusing on. Now, the probability of success, which gets denoted this way sometimes, but it also gets just denoted as P, is going to be equal to 2 out of 6, because 2 out of the 6 options are what we're looking for. This can be reduced to 1/3. Now, the probability of failure is technically, and in statistics we refer to it as its complement, and we get that Q going, and it's going to be easier for me to use P and Q, so I'm going to use P and Q, but remember Q is the same thing as 1 minus P. And what that's going to be is 4 out of 6, which will be 2 out of 3, and my advice is to go to the dentist. I'll leave that on there for a while, and I'll just say, 2/3, haha. All right, moving on. So I'm going to draw what's going on. I'm going to try and build the idea of the formula, or the where the formula comes from, and then hopefully you're going to see why we spent some time actually doing in chapter 3, I think it's 3 section 4 off the top of my head, why we did the time or working with the combination formula and the permutation formula. So I'm going to go and draw. I'm going to grab this, and now we're going to build all of the things that could happen when we do 4 rolls. So we're going to generate the probability distribution off of 4 rolls. Okay. So I'm going to sketch all of the things that could occur. Boop, doot, there we go. So on roll 1, you could have a success or you could have a failure. On roll 2, okay, so let me back up. This layer is roll 1, and this probability is 1/3, and this probability is 2/3. Okay. Now we're gonna just generate all the things that could occur. It's technically called the sample space, and so roll 2 could be, again, and remember we're trying to accumulate all the things that could happen. So roll 2 could be a success or a failure, but you have to consider the fact that on roll 1 you might have had a success or a failure. So the things that could occur at this point in time in your sample space is you could have success, 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 failure, failure, success, and failure, failure. Okay. Now, because it's a die, it's a numbered cube, the probability of success hasn't changed, and the probability of failure hasn't changed. Now, I'm not going to try and clutter this all up, so I'm just going to stop with the fractions. But just remember, each time it's a 1/3 and a 2/3. So we're now on the 3rd layer of rolls. And we have success, we have failure, we have success, we have failure, we have success, we have failure, and we have success, and we have failure. Now, we're on our final layer. Okay, so remember, and I'm going to do this in kind of colors. This V here is our first layer, and then this set of V's in sort of, I don't know what color that is, I'm going to say is like a lime green kind of thing, is our second layer, or represents our second role, but we're creating all the things that happen. So again, success, 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 failure, failure, success, failure, failure. Now that we're on the third layer, we could have had success, success, success. We could have had success, success, failure. We could have had success, failure, success, and so forth. Now we're going to go to our fourth layer. And again, we're just, because it's a binomial, because there's two options, we're always working with this like V that pops off of each possible previous pattern. And so, I'm going to draw this one carefully. So, success, failure, success, failure, success, failure, success, failure. I apologize, but I hope you'll see why I'm doing this in a bit. Okay, success, failure, and then success and failure. Okay, so all of the successes is a roll of a 1 or a 2. All of the failures is a roll of a 3, 4, 5, or 6. Okay? Now, let me do something. And I'm going to go and create a very weird color. We want, I don't know, I don't see color well enough to really do this that well. Okay, so I'm going to do dark blue. And what we're going to think about, what we're going to talk about for a second, is all of the possible paths that have exactly 2 successes. So notation-wise, what I'm looking for and what I'm working towards is the probability of 2 successes. Well, that implies that I've got 2 failures. So working left to right, success, success, failure, failure. That's one path. Now, success, failure, success, failure. That's another path that has 2 successes. Success, failure, failure, success. That's another path that has 2 successes. Failure, success, success, failure. That has 2 successes. Failure, success, failure, success. That has 2. Failure, failure, success, success. And all the rest of them have some other combination. Now, the reason I'm doing this is we have 1, 2, 3, 4, 5, 6 paths that meet the criteria of 2 successes. All right. Now, I'm going to see if I can write this better or type this out better. I may not be able to, but I'm going to give it a shot. So I'm going to go here. I'm going to go there. Click on there. I was worried about that. Okay. So let me do the following. If I can delete that, go a little bit farther. It might not let me. It doesn't look like it's going to. So just a second. Draw, erase, click, 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 click. Good. Home, go here, cursor. All right. So the probability, let me increase my font. So the probability of 2 success, and what's happening then is, and really you're having 2 failure, and it's not necessary that you're right both, but by the formula in the book, what you're looking at is, and I'm going to insert equation. There we go. So, come on. Show me equation up top. I need an equation up top in order to make this work. Insert equation. Oh, I see what I did wrong. I went to the, there we go. Now I get to equation. Good. And it should let me, oh, come on. Let me do something here. I'm going to pop that out. I'm going to go here to equation. Type equation here. There it is. That's what I'm looking for. Now I can get what I need. I don't know why it does that. Sometimes it just is. Okay, so the first thing that I need to do is I need to create a NC2, or I'm sorry, an NCR. And where is that? Can I go to accents and get it? Nope. Can I go to operators and get it? Nope. 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 Okay, so I'm going to have to use an alternate notation. So here is my C, here is my N, and here is my, oops, I don't want a capital N, I want a little n, and I want an R. So if you remember in the video that I introduced NCR, I pointed out that sometimes they have different notations. And so you can see the NCR, that way you can see it N with the C and the R. And this is the one that I typically use, but for some reason equation has changed. And that's just how it goes. And so this is one of the alternate versions of the NCR. So it's the same thing. All right, so let's click back on this. Oh, I have to get back to cursor land. So home, I go here, I click on that. Good. All right, so I should be able to reach into my equation, and I should be able to change the n to 4. And where the 4 comes is that we are rolling the die 4 times. And where the 2 comes from is that we are looking for the number of successes to be 2. And then what happens, and it's going to take a second because the equation's being funky. I'm going to need that. There we go. So what's going to happen is now you have the probability of success, the P, but that's going to be 1/3. That's our probability of success. And we're looking for 2 of those. And then we have the probability of failure, which is 2/3. And that's going to be, oops, screwed that up. Just a sec. Got to insert the the location for the exponent. So I have 2 of those. Now, just a couple of comments. This exponent plus this exponent has to add to that value at the top. This exponent, I'm sorry, this subscript 2 is equal to that subscript 2. So these 2 add up, and then that one is the same as that one. Now, this expression here, this 4 choose 2, all right, that's going to be equal to. Now, we have to go back and look at our formulas for combination. So in our numerator, what we're going to have is 4 factorial. And in our denominator, what we're going to have is 4 minus 2 factorial multiplied by 2 factorial. And then we're going to have 1/3 squared times 2/3 squared. So 1/3 squared is, let me find my times dot, there it is, times, and it'll be 1/9. And then my 2/3 squared will be 4/9. Now, the reason I'm doing all this is I'm going to try and show you that this 4 choose 2 is going to be the value that counts our number of paths. It's going to give us 6 paths that have 2 successes and 2 failures. So let me write out what happens with the 4 factorial. I'm going to hop out of that one, and I'm going to insert an equation, or insert equation again. Where'd you go? There. Good. So I need my template to show. Come on. Where are you? Insert equation. Will you work again? There we go. That's how we get there. Good deal. Okay, so in here, I want my fraction again. So I'm going to click there. 4 factorial is really 4 times 3 times 2 times 1. And now I have this 4 minus 2 factorial, which is going to get me 2 times 1. But then I have another 2 factorial, so then I'm going to have 2 times 1. Well, I'm going to now draw in here. Do this quick. So this 2 and this 1 will cancel this 2 and this 1. And this 2 will reduce this 4 down to 2. So I end up getting a 6. I have 6 paths that have 2 successes and 2 failures. And the successes are represented by the 1/3, and the failures are represented by the 2/3. Now, I don't need you to actually do this each time. I need you to understand how to get it from your calculator, but I'm just trying to show you how the formula works. But before we do that, let me do a little bit of backtracking. And I want to go to the home, I want to go to that, and I am going to try and scroll past and go to another sheet. There we go. So we are going to build the probability distribution based off of this structure, this option of all of the things that could happen. Before I do that, I just want to talk about sample space. Well, the sample space indicates all of the possible things that could happen in the sample. So you could have, and it's often that we do this with the pretty, go back here. I am on 16. Let's make sure we're at 16. Okay, so we use these sort of script parentheses to indicate it. So our sample space would be success, 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 failure, success, success, failure, success. So all I'm doing is I'm listing all of these possible paths that got generated. And so you just take the time and you follow each path. So success, 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 failure, success, success, whoops, I don't want to do that, success, success, failure, success. And then you would go success, success, failure, failure, until you get all the way across and you've got 4 failures. So I'm going to put dot, 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 and then it keeps going until you get to failure, 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 failure. And then you close that off. And the number of possible paths represent the number of options in your sample space. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So you have 2 raised to the 4th, which is equal to 16, number of different options in your sample space. This is your sample space. This is the number of options in your sample space. Okay. Now, pick up where I left off. We're going to build the probability distribution off this. So I need to insert a table. Okay, see if I can get that table too. And the number of columns, we want 2. Number of rows, we want 5, and I'll explain why in a second. So, there. So this will be our x on our first one, and this is the probability of x. And x is our focus on the count of the number of successes. So I'm just going to write it as the count of the number of successes. And really that x should stay small, but so we could have 0 successes. That would have been all 4 failures. We could have had 1 success. We could have had 2 successes. We could have had 3 successes. Whoops, and I needed 1 more in there. I forgot about the title. And we could have up to 4 successes. Okay, so this one here, if we're thinking about it, is SSSS. It's all S's. This one up here, the 0, well, that's the one that's all failures. FFFF. But this one here is all the different ways you could have 1 success. So you could have success. Let me do this. You could have success, failure, failure, failure. That's one of the ways it could present itself. You could have failure, success, failure, failure. You could have failure, 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 success, failure, and you could have failure, 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 and success. And so forth. Like that's what you're looking at. Now, the probability of 0 successes. Well, it's this path here. So it's 2/3 times 2/3 times 2/3 times 2/3. If I were to write it out, which I will do this here and just sort of indicate it, file, and I'm going to copy. Nope, it's not going to let me there. Command C, I think it let me copy it. I'll pop this down here. I'll go Alt V. It did. That's nice. Now, out of our 4 trials, we want 0 successes. So we want 0 1/3, and we want 4 2/3. So 4 choose 0. If you put that into your calculator, if you write it out in this formula, you're going to have 4 factorial, and you're going to have 4 minus 0 factorial, then you'll have 0 factorial. And I'm just reminding you that 0 factorial is weird, and it's 1. So you have 4 factorial in the top, you'll have 4 factorial in the bottom, and 4 divided by 4 is 1, 3 divided by 3 is 1, and so forth. So really all you have here is 2/3 raised to the 4th power. So 2/3 multiplied by 2/3, 2/3 times 2/3, which is equal to, I'll do this on my handy dandy graphing calculator. Oops. Shoot, keep hitting the wrong button. 2 divided by 3 raised to the 4th power, and your probability is 0.1975. So if I can get this to behave right, 0.1975. Okay. Now we're going to do the same idea. We're going to take this thing here, and we're going to edit, and we're going to copy it. And now we're looking for 1 success. So this changes to a 1, this changes to a 1, this changes to a 3. And so what's going to happen is the following. You're going to have 1/3 times 2/3 times 2/3 times 2/3. But for choose 1, if we compute that out, and I'll do it as a draw up here, it'll work easier for me, I think. So we're going to have 4 factorial. All right, let me write it this way. So it's 4 choose 1, and I'll bring back the factorial in a second. So by the formula, what I'm going to have is 4 factorial in the top. And then I'm going to have 4 minus 1 factorial. And then I'm going to have a 1 factorial. Well, 4 factorial is 4 times 3 times 2 times 1. Remember, there's a multiplication dot in between each one. And then over here is 4 minus 1, which is 3 factorial. So you'll have 3 times 2 times 1. And then 1 factorial is just times a 1. What will happen is the 3 2 1s will cancel, and you're left with 4. So there are 4 different paths that have 1 success and 3 failures. So we multiply this by 4. So we hit times 4 in there. If we travel back up and we look at, we're looking again for 1 success and 3 failures. Now let me do this with a different color. Come on. Oof. I will try it in black and see if it will show. Okay, so we want 1 success and 3 failures. Well, here's 1 success, and then failure, failure, and failure. So there's that path. That's 1. Now a failure and a success. I can't have any more successes. I just need 1 success. So there's a failure and there's a failure. So I have 1 path. I have 2 paths. Here's failure, failure, success, and failure. That's 3 paths. And then I have failure, 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 and success. There's my 4th path. So this counts the number of paths that have 1 success and then 3 failures, and there are 4 of them. All right, so I'm going to now show you how to do this on the calculator. And what you're going to do is you're going to hit the 2nd key, and then you're going to find the vars key. And what you're going to look for is binomial PDF. Okay, so let me do something here. Home, there. So you want the 2nd vars and binomial. Change this to 16. So binomial PDF. Now there's also a binomial CDF. That has its own little quirks, and I'll be able to talk about that in a minute. So binomial PDF, you hit enter on it, and if you have an old calculator, the old calculator just shows this on the computer screen. And the first thing that you list is trials. So our number of trials is 4. And then you put in the probability of success. And our probability of success was 1/3. And then, and notice I'm putting commas in between. And then the number of successes you want or you're looking for, you type in there. So in our first instance, up here where we had 0 successes, this 1 that I'm circling would be a 0. All right, so you type that in. Now, on the more current versions, you have the following show up. It says trials underneath, and that you'll put 4, and then it'll say P, and that you'll put your 1/3, and then it will say X value. And the X value is 1, and then it says paste. And I'm not a huge fan of paste, so I'm just joking around. When I was a teacher, some kids would be notoriously known for eating paste. And I say I am a teacher, but when I taught high school. Anyways, so I have the 4, I have the 1/3, and then I have the X value being 1. And we go ahead and you hit that on your calculator enough times where you hit the paste, and then you got to hit enter again, and you're going to get a value that's going to be equal to, I'll just pop it up here, forgive me. It's 0.395. And I'm going to round up to to 1 because it's really 0.6, but I'm going to keep it at 4 decimal places. So I've rounded up to the 4th decimal place. Now, this one here, this 2, we've already talked about. It has 6 possibilities. So we are going to do binomial PDF. Now, PDF does precisely one of these values at a time. CDF actually does a count. That's what the C stands for. It's cumulative. There's some tricks to it that you have to know. So, and there's some subtleties depending on your 84 calculator. So for right now, we're just going to do binomial PDF for 1/3, but our x value is going to change to 2. So you hit the second key, hit the vars key, go to binomial PDF. Your number of trials is 4. Your probability of success is 1/3, and your x value is 2. And after hitting enter a few times, you get 0.2962. But it's really going to be 0.2963 because we're going to round up and we're going to the 4th decimal place. All right, now we are at 3. So I'm going to type in, and I'm going to change this x value from 2 to 3, and I'm going to get 0.0987. 0.098. And it really works out to 88 after I round off. And then 4 successes in a row. So we're changing our x value here to 4. So a little trick, if you hit the second key and the enter key, it calls back your binomial PDF statement with the stuff in parentheses, and you just can arrow into the 3 and change that to a 4, and it simplifies the process just a little bit. And what you're going to get here is 0.0123. Now, if you add these, you're going to notice that they don't necessarily always add exactly to 1, but they are very close to 1. And they won't always be 1, but very close to 1 when you round. I said that poorly, so they won't always be 1. If you are rounding, it's often the case that it won't be 1, but it'll be very close to 1. I think I said that well, or correctly. Okay. Now, let's talk about binomial CDF. So we're going to change this P to a C. If you have a very up-to-date version, you can actually get your CDF to go between values. I don't have that on my calculator. So what binomial CDF does, so if I put in a 2 here for the x value, what it's going to do is it's going to add up the 0, the 1, and the 2. It's going to add those 3 up, and it's going to give me the value of those 3 summed. So binomial CDF counts up. It counts up from the 0, unless you have a very modern one, which will allow you to say, oh, it's got to be between 1 and 3. Like it allows you to pick the endpoints, and it'll add that up. Mine doesn't do that. Okay, so binomial CDF, if I said no more than 2, so that no more than would include the 0, it would include the 1, it would include the 2. It's going to add those up. So if you hit the second vars and you go to binomial CDF, and your number of trials will be 4, and your probability of success will be 1/3, and then your x value will be 2, and go ahead and paste it, and we hit enter, you're going to get a 0.8888. So I'm going to write this, the probability of no more than 2 successes is going to be equal to, and really what's going on is it's the probability of 0 plus the probability of 1 plus the probability of 2, which is going to be equal to the binomial CDF, where it's adding it all up for us, and you're getting 0.8889 if we go to the 4th decimal place. And if we check this, it's going to be close. Again, we rounded, so it's going to be, there's going to be error built in, but 0.1975 plus 0.3951 plus 0.2963, and we get 0.8889. Okay, so if you add those up, you get that, and the CDF does that for us. Now, sometimes they'll ask a question like the following. What if they say, where'd that go? Went down the next line. The probability of at least 2 successes. Well, that can still be done with this, but it's a little bit of a trick. So what we're going to do is I'm going to write this out. I'm going to draw this, and it helps if you actually visualize it. So you have the 0, you have the 1, you have the 2, you have the 3, and you have the 4. And it says at least 2. So at least includes the 2. If I am at least 50 years old, which I'm significantly older than that, but if I'm at least 50, I could be 50. So that at least, the at includes that 2. So we want the probability of these 3. Now, what that's going to mean is, let me get my cursor over here. What that's going to mean, come on, work with me. I got to scroll down. Come on, work with me. Where'd you go? Well, it disappeared. Oh, there it is. Okay. So I want at least 2. That's going to be the probability of 2 plus, shoot, my font got switched again. There. And then the probability of 3, and then plus the probability of 4. Well, your calculator doesn't have that ability unless you have the more modern version. So what we're going to do is we're going to use the idea of the complement. And the complement is the idea that all the probabilities will add up to 1. So what I can do is I can say I'm going to take 1 and I'm going to subtract off the probability of 0 as well as the probability of 1. So if I do the following on my calculator, 1 minus, and then I do the second key and the vars key, and I look for binomial C. I'm highlighting the C by making it capital there, CDF, and what I type in is for my trials 4 and my probability of success 1/3. And then what I put here, and the reason I did that drawing that got sort of shifted around, and I'll try and redraw it real quick. Draw here? Okay. So we have 0, we have 1, we have 2, we have 3, we have 4. These are the 3 probabilities that we're trying to add up. But if I add these 2 values up, these 2 probabilities up, and I subtract it from 1, I'll get this probability. And so what I'm going to put here is the 1 that comes from that piece right there. And what that's going to be equal to, so we're going to go 1 minus second vars, go to binomial binomial CDF, forgive me. And what we want in our x value is going to be 1. Our trials are 4, our p is 1/3, and our x value is 1. And we hit enter a couple of times, and we're going to get 0.40740. So 0.4074. And the next value is 0. I'm not rounding to anything farther than the 4th decimal place at this point in time. Okay. That was a long video, and I apologize, but understanding how the binomial PDF and stuff ties together, and the binomial CDF is going to help us out in the long run. All right. I hope you have a good day.